Hello, everybody. Welcome to the Naperville Astronomical Association's fundamental program. So the last few years we've tried to do a summer program specifically for kids. And the way we handled this is we had some kids send in their questions, and then we've kind of done our best to try to answer those questions. So we will also try to answer questions afterwards. So if your kids or even you have any questions, you can put them in the Facebook chat and we'll try to answer those, or you can email us at questions@naperastro.org. So let's just jump right in. I'm going to shut my camera off here. And our first question comes from Margie.
Hi, my name's Margie and I have a question. Why is the sun yellow?
So why is the sun yellow? So it's a really good question, but the answer is that the sun is not yellow. The sun's actually white. And the way we can tell that it's white is when the sun shines on clouds or on the snow, those things look white. They don't look yellow. The other way is through a prism. A prism actually breaks that white light up into different colors, and you see the same thing when you look at rainbows. It scatters the light so you can actually see the different colors. I have a little. Mostly the sun looks yellow more in the evening or when it's lower in the sky, and the reason for that is because of how the different color wavelengths travel through the atmosphere. So when the sun's high in the sky, it will actually look white, but when it's lower in the sky, it'll actually look yellow. And I have a little video that I found that kind of explains. The video is more about why the sky is blue, but it kind of talks to you about how the light gets scattered. So I'll just play this little video for you guys.
Ever stop and look at a sunset? Wonder why there's so many colors. When the rest of the day, the sky's just blue. It all has to do with light. Light from the sun looks white, but it's really made up of all the colors of the rainbow. You may have seen sunlight sparkling through a sprinkler in the yard or a fountain in the park, and a rainbow suddenly appears. The water helps to separate the sunlight into different colors, but you don't have to wait for that to happen. To see all those colors, take a prism, especially say crystal, and shine light through it. When a ray of light enters the prism, the light slows down and bends. Different colors of light bend different amounts. So, the light will separate into all its colors. All light travels in a straight line, unless something gets in the way and reflects it, like a mirror, bends it like a prism, or scatters it like the molecules of the gases in the atmosphere. Sunlight reaches the Earth's atmosphere and is scattered in all directions by the gases and the particles in the air. Blue light scatters more than the other colors because the blue waves are shorter and smaller. That's why we see blue skies most of the time. So why do sunsets sometimes look yellow and orange and red? Well, as the Earth turns and the sun gets lower in the sky, the light from the sun has to travel through more atmosphere to reach your eyes. This means there's more time for the light to scatter. Even more of the blue light is scattered, but the reds and the yellows, which travel in longer waves, don't scatter as much. So, more of those colors pass straight through to your eyes.
Okay, so I hope that kind of explains a little bit about how the light waves, how the light gets scattered and why the sun looks different colors. I'll get past this. Okay, our next question is from Emily.
Hi, I'm Emily. I want to know what the sun looks like.
So again, this question's about the sun. So it's kind of hard to see what the sun looks like because it's so bright. When we look up at it in the sky, it kind of hurts our eyes. We have to put on sunglasses, or we've all been told not to stare at the sun. So some of us amateur astronomers and professional astronomers have special telescopes that let us look at the sun. And what these telescopes do is they block almost all the light. It's like really, 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 really dark sunglasses that are blocking so much of the light that you can actually start to see some of the features. And some of the features that we see on the sun, so if I go back, this telescope on the left is called a hydrogen alpha telescope, and this telescope on the right is called white light. And those two telescopes show different things. So the white light shows things like sunspots, which these are colder areas of the sun. And sometimes these are really small, sometimes they're really big, but these are features that we can see on the sun. The hydrogen alpha telescope shows us a lot more detail, and one of the big things and the prettiest things we can see are these what are called solar prominences, and this is basically, think of it as kind of gas coming off of the sun, and it comes off on these in these arches, and then sometimes they last a few hours, sometimes they last a few days, but then usually gravity sucks that back down to the planet, or to the sun. And then there's also filaments, and these filaments are the same thing as a prominence, but they're facing us, so they kind of look like these little snakes or these little worms on the sun. And then something that's very cool that we can see, but we can only see it at certain times, is called the corona. And this is really, really, really hot stuff. This is like 30 million degrees, but we can see this corona during something called a solar eclipse. And these don't happen very often, but when they do happen, we can see this corona. Okay, the next question is from Gabby.
Hi, my name is Gabby, and I have a question. Why is the supermoon so big?
Okay, I'm going to turn this over to Matt to answer this question. Matt, you ready?
Hello. Yeah, the supermoon is when the full moon looks bigger than at times rather than other times, and the supermoon happens when the moon is closest to the Earth at full moon. So we have the moon orbits the Earth, and that orbit isn't a complete circle, isn't a perfect circle. It's a little bit elongated. This image here is kind of tilted, but you can see that the one side, the moon is closer to the Earth than the other side. When the moon is at the farther away part of the ellipse from the Earth, that's called apogee. And when it's closest, that's called perigee. And then the supermoon happens when the moon is at perigee and it's a full moon, which means the sun is on the opposite side of the moon from the Earth. So the Earth is in the middle, the sun's on one side, and the moon is on the other. That's when we see a full moon. And so the supermoon is the perigee full moon.
And here's a little video that kind of shows the difference.
So yes, we see that at apogee, it's a little farther away. And because it's farther away, it looks smaller. When it's closer at perigee, it looks bigger. But it's really not that much of a difference. I've seen where it's somewhere in the neighborhood of 10% or less. So it's really not that big a difference. And when you look at the moon in the sky, it's not going to look that much. You're not going to be able to see that much of a difference unless you have some sort of way to measure. Here's a picture of the micromoon, which is the apogee full moon, the average full moon, and then the supermoon, which is the perigee full moon. So why does the moon look so big when it rises? We've seen this sometimes. If you've watched the moon and you've seen it close to the horizon, there's an effect. It's an optical effect that the moon looks really big when it's close to the horizon and it's just rising over trees or buildings. And the reason for that is an optical illusion, where the image looks, things that are, our mind thinks that things that are closer are bigger and things that are farther away are smaller. And when, like in this image here of the railroad tracks, that red line is the same length in both those instances. But because of the optical illusion of the railroad tracks, thinking that that top one is farther away, it looks bigger than the red line that's at the bottom of the picture, which your mind thinks of as being closer. So when you look at the moon, you have that same perspective railroad track effect in play, and you see when the full moon is close to the horizon, it looks a lot bigger. But when it's up higher in the sky, it looks smaller. But when you go to measure it, you can see that it's the same size in both times of the night. And you can measure it yourself. You can take your thumb, and when the moon is near the horizon, hold your arm straight out and then cover the moon with your thumb. It'll completely cover the moon. And then later on in the night, when the moon rises higher in the sky, do the same thing. Hold your arm out straight and cover the moon up with your thumb, and you'll see that the moon is the same size. Even though when it was close to the horizon, it looked really big.
All right, thank you, Matt.
Mm-hmm.
Our next question is from Owen.
Hi, my name is Owen, and I'm 5 years old, and my favorite planets are Earth and Mars, and US Scuti is known as the biggest star in the galaxy, and it's in the middle of the Milky Way. And my question is how Pluto was formed.
So how Pluto was formed. So until a few years ago, we actually had no idea what Pluto looked like. And I think it was in 2014 or 2015, we had the New Horizons satellite fly by and image Pluto, and we got to see it for the first time. So Pluto was formed basically the way all the other planets were formed. And we have a little video here that can probably demonstrate this a little better than I can talk about it.
Space place. In a snap. How did our solar system come to be? The solar system is a pretty busy place. It's got all kinds of planets, moons, asteroids, and comets zipping around our sun. But how did this busy stellar neighborhood come to be? Our story starts about 4.6 billion years ago with a wispy cloud of stellar dust. This cloud was part of a bigger cloud called a nebula. At some point, the cloud collapsed, possibly because the shockwave of a nearby exploding star caused it to compress. When it collapsed, it fell in on itself, creating a disk of material surrounding it. Finally, the pressure caused by the material was so great that hydrogen atoms began to fuse into helium, releasing a tremendous amount of energy. Our sun was born. Even though the sun gobbled up more than 99% of all the stuff in this disk, there was still some material left over. Bits of this material clumped together because of gravity. Big objects collided with bigger objects, forming still bigger objects. Finally, some of these objects became big enough to be spheres. These spheres became planets and dwarf planets. Rocky planets like Earth formed near the sun because icy and gaseous material couldn't survive close to all that heat. Gas and icy stuff collected further away, creating the gas and ice giants. And like that, The solar system as we know it today was formed. There are still leftover remains of the early days, though. Asteroids in the asteroid belt are the bits and pieces of the early solar system that could never quite form a planet. Way off in the outer reaches of the solar system are comets. These icy bits haven't changed much at all since the solar system's formation. In fact, it is the study of asteroids and comets that allows scientists to piece together this whole long story. Brought to you by NASA's Space Place.
Okay. I hope that answered your question, Owen. It's kind of difficult to explain, even for me to understand how the solar system was formed. Okay, our next question is from Elizabeth.
Hi, I'm Elizabeth. Are there aliens in space?
So, are there aliens in space? So that is a very good question too. And so far we don't know the answer. When we think of aliens, we think of the aliens that are on different TV shows or movies, and sometimes they're cute, and sometimes they're funny, and sometimes they're strong or smart, or they can do a lot of different things. And then some movies have, mean aliens and scary aliens and the guys out there that we need to be afraid of. And probably the first time we discover life, it's probably going to be more like bacteria or amoebas or something that's floating in a lake of liquid methane. It's probably not that we're going to find an alien fly up in a spaceship and come out and say, "Take me to your leader." It's probably going to be something like this, or it might be we find bacteria, but it's all dead bacteria, which that tells us that there used to be life there, but there's not life anymore. So we keep looking for things that are called exoplanets, and we have satellites that listen, and we try to listen to radio waves, and we look at all these different areas of the sky, and we keep finding more and more things. We found 4,434 exoplanets. So these are planets that are around other stars. We have over 7,600 that we think are probably planets around other stars, and so far confirmed we have 3,288 planetary systems, which that means some of these systems have multiple planets. Some of these stars have multiple planets going around it. And I think in the scope of the galaxy, you have to think that most stars have planets, and then most exoplanets probably have moons, and the ingredients to make life or just exist everywhere. So there's a really, really high chance that there's aliens somewhere. They might be really, really, really far away, but there's probably life on some planet somewhere. But as of right now, the only planet that we know has life is the planet Earth. So thank you for that, Elizabeth. All right, our next question is from Jacob.
Hi, I want to know how many galaxies there are.
So that's a really big question too. So this is a picture of the Hubble Deep Field. This was taken several years ago. I don't remember the date this was taken, but this would be the equivalent of if you were standing at a football field and there was a tennis ball all the way at the other end of the football field, and you had your telescope zoom in on that tennis ball. And once they took a picture and they left the camera running long enough, we got this image. And they were looking at a part of the sky that really had no stars in it. And every single little dot, every little speck in this whole picture is a galaxy. So scientists have tried to estimate, based upon this, how many galaxies there might be, and there's a really big gap. I mean, really, we don't know the answer, but there's a big gap, and it's somewhere between 200 billion and 2 trillion. And these are numbers that are hard to even wrap your head around. One way to think of it is if you go to the beach, every little grain of sand on the beach you're at, and every beach in the entire world, all those little tiny bits of sand would be less than all the stars that are in our universe. So, it's a really, really big place out there. But I don't know if we'll truly ever know the real number of galaxies that are out there. This question is from Jacob.
Hi, I'm Jacob from Algonquin, Illinois. My question was, what was the farthest planet we've ever seen?
So what was the furthest planet we've ever seen? So this is a picture of what we think the Milky Way probably looks like. So we have looked close to the center of the Milky Way, and what I saw was we were about 27,710 light years away. So it's pretty close to the core of the Milky Way. They actually detected 2 planets. They were called Sweeps 11, and this planet they think is probably a little bit bigger than Jupiter, and it goes around the star every 1.8 Earth days. So that means by the end of this week, if you lived on that planet, you would be like 3 or 4 days older, or 3 or 4 years older, because it goes around the star very quickly. And then the other one, I think it's in the same system, is the Sweeps 4, and it's a little bit smaller than Jupiter, and it orbits so it goes around its star every 4.2 days, which is really fast. It takes us 365 days to go around our star. One of the ways, so this SWEEPS stands for Sagittarius Window Eclipsing Extrasolar Planet Search. And really the way they do it is they can detect as a planet goes in front of its star, as you can see in this little example here, it makes the light get a little bit dimmer, just the tiniest bit. And when they see that happen, they think, okay, well, there's a pretty good chance that this star might have a planet around it. But they need to confirm that, so they need to keep watching it and see if it makes these similar dips in the light on a certain period. So, like I said, that Sweeps 11, every 1.8 days, it went all the way around this circle. So every 1.8 days, they could watch this dip happen, and at that point, they realized that, okay, this is definitely a planet, because the star is not going to dim on a schedule like that, but a planet would continue to orbit at a certain rate. Okay, and our final question, this is from Bennett.
Hello, my name is Bennett. I live in Algonquin, Illinois. And my question is, what is outside the universe? I mean, some people think the universe is infinite and that the universe is everything. But what is outside of everything?
So this question actually was the hardest for me to answer. So if you think about it in one way, if the universe is infinite and if it's everything, then that means there's nothing outside of it. If you have a jar of candy and all the candy is in that jar, and you say, well, how much candy is outside the jar? Well, the answer is none, because all the candy is inside the jar. So the kind of the easy answer is to say, if the universe is everything, then that means there's nothing outside of the universe. There's a few different theories about the universe. When I look at astronomy, I see that most things, gravity likes to take most things and make them round. So there's definitely a theory that the universe is round. So if you were traveling on a really, really, really fast spaceship and you went in one direction and you went long enough, you eventually would circle all the way around and you would end up back where you started. There's other theories that the universe is flat, and that means that it's, I guess the best way to say it is, it's as the universe is expanding, it's stretching. But we don't know the answer. It's all theories at this point, because the universe is so big, you kind of can't tell. When something's so big, you can't tell it's round. It's like when you stand outside your house and you look at the road looks flat, but the Earth is so big that if you kept following that road, you eventually would walk around the Earth in a circle. So even though it looks flat, it's actually still round. Now, one kind of theory that scientists have about the universe is there might be something called a multiverse. And this means that there might be several different universes. So Bennett, to answer your question there, if you believe in the multiverse theory, outside of the universe, there might be a whole other universe. And when you think of that, I mean, my brain can't even think of how big everything is if there's multiple universes. I can't even think about our just one universe, how big it is, let alone multiple universes. So it's a very good question. It really made me have to think a lot on how to answer that. Okay, so those are all the questions that we had submitted. And I really want to just take a minute to thank all these kids. A lot of these questions were more difficult to answer than I thought that they would be, which just goes to show that kids are maybe a lot smarter than we give them credit for, because they're thinking about things in a way that maybe adults don't think about things anymore. So I really, really appreciate all the questions that we got. Doesn't look like we have any questions on the internet, on Facebook. So that might be the end of our presentation. So thank you all for watching. We really appreciate it. Next year, hopefully everything with COVID is over and we'll do our family program indoors, and usually we have fun activities for the kids to do, but this year we still did it online. So thank you very much for joining us, and I hope you all have a nice evening.